Hey, World of Inquiry students, this is Mr. Balzer again. So far we've talked about um, distance and displacement, speed and velocity, and we've been talked about moving cars and balls rolling and stuff like that. Today we're talking about acceleration. It's building off of those topics. Speeding up, slowing down, and turning. Our learning target for the day will be I will be able to use acceleration to describe when an object speeds up or slows down. The last part, we're going to talk about that in a minute. Okay, so what is acceleration? Well, if we think about the objects that we have talked about so far, they've been moving with what we call constant velocity. And objects don't always move with constant velocity. Remember how we do notes? You just highlight the word and turn it red as we go along. But what does constant velocity really mean? Well, constant velocity really means that we're moving at the exact same speed and in a perfectly straight line. You remember velocity is a vector quantity, and it has two parts. It has a magnitude or size, and it has a direction. Now, if you think about a car, there's sometimes we'll need to oops, start from a stop. We will need to oops, slow down and come to a stop, or we will have to come on, turn right or left. All of these will change your velocity. Okay. Now, the turning right and left, you can do that at a constant speed. But when those, you're changing your direction, which again is part of velocity. So we'll talk a little bit about that later on. Now, the term acceleration, when you talk to your parents or your friends or somebody that's not in a science class, not in a physics class, they generally think of acceleration as just something speeding up. Okay. The gas pedal in your car is actually called the accelerator. Now, these people you're talking to, they also may use the term deceleration. Deceleration is used when something slows down. So when something slows down, we generally say that it decelerates. But really, when we're talking about it in physics, and we're going to be using equations and using numbers, the magnitude of the acceleration, right? It's the number part. We will be using a negative number. So if we talk about a negative acceleration, that generally means that we're slowing down. Excuse me. Now, as for turning, we'll look at that later in the course when we start talking about circular motion and projectile motion. It's not that hard, but we do have a different set of rules and different things. So acceleration is, and I should have done this, so I'm going to highlight it. This is my check to see if you guys are actually watching the video. I'm going to highlight this in orange. So acceleration is a vector quantity, which means it's going to have a magnitude, the number part, and a direction that describes the timed rate of change of velocity. Now, that's a lot of words, but really we can sum it up in one quick equation. Acceleration is delta V over t. Now, the triangle, and I'm going to insert this here. Just go up to insert, equation, just like we've done before, and it's a Greek letter. You can actually see it there. So just find the deltas. It's a little triangle. It is called delta and means change in. Okay, so I'll put that little in there. Again, I want to do this. So what we mean by that is, and I'm just going to highlight that in orange, that the velocity is going to change. So if we're going 5 miles an hour and we step on the gas and we go to 12 miles an hour, we've changed it by 7. Or if we're going 12 and we step on the brake and come down to 5, We've subtracted 7. We'll be working on this. This is a concept that we'll be talking about for weeks. Okay. Now, another way to think about what acceleration is how quickly we pick up or lose speed. I'm just going to put that on the next page because it's all the same. So, what are the units on this? Well, if we take our equation, we can figure this out pretty quickly. Velocity is going to be in meters per second, and the time is in seconds. So, if we think about this for a second, velocity is meters per second, division means per, and time is seconds. So, the first way we can think about the units of acceleration are just meters per second per second. So, what we're going to say is, let's say that we're going to have a car and it's going to roll down a hill, or a ball that's going to roll down a hill. Well, it's going to start off with no speed, 0. If it has an acceleration of 5 meters per second, that means that every second it's going to gain 5 meters per second of speed. So after 1 second, it'll be 5. After 2 seconds, it'll go 10. After 3 seconds, it'll pick up another 5 and be going 15. So that's really what it means. Now, mathematically, we don't want to write that all the time. We don't want to say that all the time, meters per second. It gets a little weird. But if you're dividing by a second and then divide by a second, just like in math class, we can square those seconds and talk about meters per second squared. Now, a lot of times we don't even want to write it out, so we're going to abbreviate it. Oh, where'd it go? Oh, there it is. I had a little tough time finding that little bugger. I'm going to make him bigger. Meters per second squared. So you'll put the meters on top and squared seconds on the bottom. It's really just meters per second, just written a little nicely. Now, another equation that we're going to use, since we're changing velocity, just like if you change anything, you have a starting and a stopping. You can actually talk about average. And we can find the average speed of an object. Another way we could, because we talked about it last time, is if we're accelerating, we can just take the two speeds, it's starting and it's stopping, add them up and divide by 2. You know? So again, if I start off, let's take that ball rolling down the hill example. If I start at 0, and then I know it's going 10 at the bottom, say accelerate for 2 seconds. Well, what's the average? 0 plus 10 divided by 2. The average speed would be 5. Okay? So it's a little bit. Now you're going to look in the reference table and you're going to see some other equations that are very useful. And we will be using these all the time. So there'll be questions that we ask about the final speed while accelerating. Well, there's an equation for that. There is an equation for finding the distance that we're accelerating. We could always find the distance in the previous problems when we're moving at a nice even speed. But now we have an equation that will give it to us if we're accelerating. And we'll talk about that. And then there's one without distance at all, because that we call the time independent equation. You don't need time for it. Every equation up to this point has had time except for this little guy up here. So again, these equations here, especially these last two, we will be going over at a later date. So what I'd like to do is just 2 simple problems today, just to get our feel for this, and we'll see what we can do. So a car is traveling on a straight road at 15 meters per second. It accelerates uniformly to a speed of 21 meters per second in 12 seconds. The total acceleration during the 12 seconds is A, negative 0.5 meters per second squared, B, 0.5 meters per second squared, C, 2 meters per second squared, and D, 3 meters per second squared. Now, right off the bat, you have to go back and talk about what the acceleration is. Acceleration is changing speed over time. So I'm going to make sure I write that in. Oops. I'm actually going a little low. Well, I'm going to pause the video for just a second. Okay, so when we're doing this, let me just scroll this up a little bit. Use the mouse pointer. When we're doing a problem like this, what we can do is take our acceleration, a equals delta v over t, and we can actually figure this out. So a will be the change in speed. So if we started at 15 and we go up to 21, our change in speed is 6 meters per second. And that's going to be divided by the time. It took me 12 seconds. So when we do the division, 6 divided by 12 is a half, or 0.5 meters per second, or as we said, when you simplify this, 0.5 meters per second squared. Oops, I guess I gotta move myself out of the way. I'll move myself up here. Okay, so that's pretty basic, and that gives us an answer of B. Okay, so now let's move down and we'll talk about number 7. And again, our learning target's right there. It's a little weird how we can see my writing up there. Okay, so the learning target still is I will be able to use acceleration to describe when an object speeds up or slows down. So now we have a race car. A race car starts from rest and accelerates uniformly at 4.9 meters per second squared. If it accelerates for 2 seconds, what is its speed at this time? Now, sometimes we're going to have to talk about hidden information in the problem. And we're starting from rest. So I know my starting speed, V, and I'm going to call it VI for initial. That's going to be 0, okay? Because I'm starting from rest. I'm not moving yet. But then I'm going to step on the gas, or the race car driver will, I guess, and my acceleration will be that 4.9. And I actually do like to write out these things on problems. So on scrap paper, you're going to have to do this. Now, if it accelerates for 2 seconds, what is the speed at this time? So this is really a final speed. So it's a speed, and I'm going to put a little f for final. And that's what we're looking for in this problem. So let me just scroll down a little more and give myself a little bit of room. And we're going to, again, look at our A equals delta V over T formula. So we can find out how much our speed changed, and then we'll just add that to what we started at. So I started at 4.9. Oops, sorry. That's my acceleration, so I'm going to plug that in. And I want to find my change in speed over that 2 seconds. Now, if you remember from math class, come on. I want to change color. Okay, it's not letting me change color really easy. What we would do is we'd put that over 1 so we could cross multiply. So my change in time, or my change in speed, change in speed, why did I do that? Change in speed will be 2 times 4.9, or 9.8 meters per second, because we're talking about speed. And if you do the math, one of those S's will cancel with that S. It's a little algebra. Now, If we started at 0 and we added 9.8, our answer will be 9.8 meters per second. So that's the very basics of acceleration. We will be using this, so don't worry if you don't have a total grasp on it. Remember, we're building on things. So we'll work with this next week and probably the week after when I'll do some video labs and stuff like that for you guys. So what I want you to do is make sure you turn in your notes when you get done, hit the turn in button, and I'll see you next time.